Hello everyone, welcome to my talk on simplifying your AI and ML using the Databricks feature store. My name is Debu Sinha. I am a senior specialist solutions architect at Databricks focusing on AI and ML use cases. Prior to joining Databricks, I was a senior solutions architect at Lifion by ADP. I also co-founded a company that is into the edtech space called Throttle Onboarding. And prior to that, I have worked as senior software engineer and software engineer at various companies on big data and ML initiatives. I have also completed my master's with thesis on machine translation from Johns Hopkins University. So today's agenda is packed and we are going to cover a lot of details today. By the end of this talk, you will have a good idea of what a feature store is, what are the motivations behind the development of a feature store, and how you can utilize the feature store that is built into the Databricks platform to power your ML and AI initiatives. So let's get started. So if you take a look at the ML lifecycle, there are typically these steps. You have the data engineer that is responsible for generating these data engineering pipelines. Then the data scientist is there, which takes these data pipelines which land the raw data into your data lakes or delta lake, do some feature engineering, do some data discovery, and after doing the model training and validation, put your model into production or hand it over to the ML engineers, which productionize the model and then perform monitoring around it, and this cycle continues. So let's take a look at what actually is a feature. So feature in a nutshell is just a column or a data point from your raw data set that is used by the machine learning engineers or the data scientists to perform feature engineering. So for example, if this is a data set containing the records of all the sales performed for a particular store, then the quantity is one numeric feature. You have the product IDs, customer ID, and store IDs, which are other sets of features. So essentially, the raw data set contains different columns and they are your features. Now the term feature engineering is essentially where the data scientists come in and they take this raw data set and mix and match with the other data sets that are available into the lake house or the data lake. They combine it and they can perform different sorts of operations like data transformation, like treating the skew or standardizing the data. They can be performing data augmentation, like from the date they may be extracting what was the season, what was the time of the day, weather, have those contextual features derived from your data set. And they can also perform data aggregation, in which they can compile in the past 7 days what was the total amount of sales for a particular product that happened for a particular store. And in this case, if you're trying to predict in future, if you're trying to forecast what is the sales, then that will be the type of feature engineering I will be performing or the data scientist will be performing. And in a nutshell, when your features are generated, like after feature engineering, it goes into the model for training, and then at the time of inference, the same set of features usually go into the model and you provide inputs to the model and outcome the inference. So let's take a look at the motivation for feature stores. We discussed that the raw data makes its way into your data lake through the data engineering pipelines, where the data scientists pick it up and perform the entire ML development lifecycle. So in this diagram, we are actually summarizing that journey. So you have your raw data, which is now in your data lake. It may be streaming as well as available in your cloud storage. The data scientists use different libraries. They may be using pandas or different sorts of libraries to perform feature engineering. And ultimately, they perform their models based on their use cases and hand over the logic to the data ML engineers for productionizing the model. So there are a couple of challenges with this kind of approach. First of all, there's a duplication of feature engineering logic, because essentially the data scientists are creating multiple models at the same time for solving a business problem. Now a team of data scientists may take a look at this raw data set that is there and create their own feature engineering logic which may have already been created and worked on by other set of engineers or data scientists. So as a result, there's duplication of the effort, and this happens because the features that were generated by maybe team 1 was not visible, or it is not easy to discover them. Apart from that, there's no reuse of features because lack of discovery, lack of visibility into the existing set of features. And there's an online and offline skew because the training environment, like the data feature engineering logic that was created by the data scientists, may differ from the feature engineering logic that was created by the machine learning engineers. And this may cause problems when you take your model from training phase to the deployment phase. So essentially, this is where the feature store comes in. So feature store is a central repository for all your features. So your raw data makes its way into your data lake. The data scientists perform the feature engineering and then later on publish that entire data into a central repository, which is a feature store. And at the time of model training and inference, the feature store is the source of truth for all the features that are utilized by your model for training as well as model inference. And this eliminates the online offline skew. It eliminates the duplication of the feature engineering logic. So at a high level, if we look at the implementation, the feature stores have two components: the batch component or an online component. The batch component, like depending on what kind of use case you are implementing, you may have latency requirements for your features. So if it is a batch or streaming, then you may be content with using a feature store which is not having low latencies, and is not backed by a relational database or maybe a NoSQL database. However, if you have a use case in which you have to serve a model through a REST endpoint, and at that time you need to have the features coming in or retrieved from an online store in near real time, so that's where you have the online feature store. So typically this is how the entire end-to-end feature store implementation in your machine learning lifecycle will look like. You have your raw data. Your data scientists come up with the featureization logic. They perform the feature engineering on the raw data and register it into the feature registry. Now, feature store has two different types of storages. One is the offline feature store for batch and stream, and the other one is the online feature store for real-time low latency feature retrieval that can be used by your client applications with low latency. So let's take a look at the implementation of the feature store within the Databricks platform. So in the Databricks environment, the feature store is co-designed with Delta Lake and with MLflow. So Delta Lake is an open format. It provides ACID transactions, schema enforcement. It has a lot of different features that are really useful and provide optimizations, like it unifies the batch and stream processing APIs. It has indexing, file skipping, compaction, and caching built in. It also provides versioning and governance and native access through PySpark and SQL, etc. There are many more features associated with the Delta Lake. I can provide the link at the end of this presentation that you can go and learn more about. It is co-designed with MLflow, which provides an open format that supports all your machine learning frameworks, and it packages your machine learning model version as well as your feature version with your model itself. So let's take a look at a demo of how this can be implemented within Databricks environment. So what you see in front of you is my Databricks workspace. I'm making use of the feature called repository. If you're familiar with Databricks, this is the feature that allows you to integrate your GitHub repository, like your code base, for version control with the Databricks workspace, and you can do all your deployment development in this with CI/CD and testing and all the best practices. So what we are going to do here, this is a very popular data set from Kaggle, and we are going to do the classification of the survival. We are going to predict whether a person on the Titanic will survive or not. I'm loading all the configs, like I have created a separate file with all the configs, like that defines it's part of the setup, and you will be able to find this code in my GitHub repository. So essentially I'm just reading this table. My raw data set is backed by a delta table right now. I took the data and created the delta table. So it has passenger, survived, P class, name, age, sibling, and this is how my raw data set looks like. Now there are certain features which have missing data in them, and as part of the feature engineering I'm also removing the different separating the different features into their own groups. So I am taking out the demographics, like I create a feature table called demographics for just containing the passengers demography information. I have a ticket info which gives me the reservation details of the particular passenger, and then I have separated out the labels associated with the passenger ID, whether they survived or not. So here, once I have my data, I'm separating out my different feature tables, and the way I am utilizing the feature store in Databricks environment is essentially define offline feature store table. I am utilizing the feature store client. You simply go in, you define the feature store table name, the schema. So this is the schema of your data frame that you want to have as your offline feature tables schema. What will be the key? So you can have a single key or a composite key for lookup. This will be used at the time of inference or training when you're trying to get the features from the feature store based on a key. And you can also provide a comment here. I create the description, so this creates two offline tables or feature tables. They are backed by Delta, but it has some additional benefits. Now you have a feature store. If you go in, you can actually see the table or the features that I have created. Let me execute all the code first. So this is how my raw data looks like. Just to show you how different types of feature engineering can be done, I am separating out the features into their own different feature tables, like separating the demographics, the reservation info, and whether the passenger survived or not. It's a label itself. And I'm separating it because in real world, you may have labels coming in much later than the actual features. So you may not have the features as part of the raw data set altogether. So it kind of mimics how your real world use case will look like. So once I define my offline feature store tables, this is creating the data into my table, which I can visualize if I go into my data tab. Now I have a Titanic passenger survival features, and it has two different feature tables. These are the offline tables, which Titanic passenger survival demographics and the ticket info. I can also take a look at these feature tables if I go here in feature store and take a look at the Titanic demographics as well as the Titanic ticket info. This gives me information about if there's any partition key, what are the primary keys. So here I'm utilizing the passenger ID as the key that will be utilized. Right now, no model or endpoint is utilizing this feature, so there's no lineage being shown here. But that's an important feature of the Databricks feature store, that once we start using this feature table for model training, it will show us all the downstream models that have been utilizing it, or if we are utilizing this particular feature into our notebook. So you have end-to-end lineage. So it shows when was this created, feature table created, and who created that. And you can add permissioning around it as well, like who can access it. either through API or through the UI. So going back, now I have all my data ready into my offline store. Now additionally, I will also create a feature table into my online store. So the way it works is, first, if new data is coming in and you have a requirement that you don't want to you want to deploy a model not only in batch and streaming fashion but also as a REST endpoint, then you need to have an online store. And Databricks feature store, at the time I'm recording this session, you can have multiple options, like you can use DynamoDB, you can use Amazon RDS, MySQL. So here my feature store, online feature store is Azure. In Azure I'm utilizing MySQL. So here what I'm doing is, any new data that's coming in, like with the merge mode, it will see if the passenger ID is already in the table, it will merge the new data. So in your case, in this dummy data set, it doesn't make any difference. However, in your case, if new data is coming in and you have a key in your feature table for a customer profile, for example, then the customer profile will be updated with the merge available here. Now, in order to publish this feature table into my online store, I need to have the database access, like the relational database or DynamoDB access. And here I'm simply providing my Azure MySQL spec, because I'm using Azure, but you can use other clouds as well, as I mentioned earlier. So I'm creating the following two feature tables: the demographics online feature table and the reservation online feature table. And again, I'm doing a merge on them. So as soon as I run this, I will have these tables available for me into my online feature store. And just to show that, like this tool is actually connected to my remote MySQL server, where now my database name, where I am keeping my features tables, is Debu online feature store. If I refresh it, it has my two tables in there, the passenger demographics and the ticket info. So let's take a look at them fitting our model. So model training, essentially, again, I'm loading my config. I have a file called functions. Like if I open it, it opens into a new tab. And here I have defined my feature engineering logic. So when I created this feature table, I used the same file. So same logic was utilized both at the time of feature creation, and we will call this same set of functions when we are training our machine learning model, so that the feature engineering logic remains same. So here I'm simply making sure that I'm extracting certain title from a name if it is given. I'm making use of something called as a pandas UDF here. So I give in a name and it extracts a name. There are a couple of other feature engineering processes that I'm doing here, like extracting the ticket, from the ticket the characters, and also the cabin characters. So it is extracting, like if I give a cabin number, then it extracts the character from that. So these are just simple feature engineering methods which can be utilized both at the time of feature engineering, when the new data is being populated into your feature table, and also when a new request comes in, like we will see how this same set of functions will be utilized at the time of inference. So here I'm just importing the libraries that are needed. I'm setting my experiment. So here in MLflow, like if you are familiar with Databricks environment, there are two separate types of experiments that you can set up, where you are going to track the model training and inference. One is the workspace level, as well as another one is the notebook level. So this one, since I'm setting up with a name, it's explicitly, this is my workspace level experiment. To train a model, I have to create something called as a feature lookup. The feature lookup combines the feature from the multiple feature tables that I have created. So I'm going to use my reservation info feature table, my demographics feature table, and it will be joined on the basis of the lookup key, which is my passenger ID. Now once I have my feature lookup, I'm also going to provide the label that is present for my survival or not in order to create the training set. So my training set takes the feature lookups, like it will combine the features from all the tables or the feature tables, and it will combine the label from my label table, which is not a feature table. So here, once we have the data available for us for training, I'm simply using XGBoost classifier at the end of a pipeline model to perform my classification. So my pipeline looks like this. It has the pre-processing, which has the transformer, and the transformer contains column transformer that is taking the categorical variables and generating categorical features, like it's encoding them, and we have the numeric features, which is also imputing the missing values. Now I'm going to create a custom model. I could have not used the custom model, but this showcases how you can utilize your pre-existing models, wrap it into your MLflow custom model wrapper to utilize with Databricks. So here I'm just creating the model that I trained earlier. I have inserted it into the fit method here. Whatever input goes in to my custom model, it will be inferred using the model that I already trained earlier, XGBoost pipeline model. And at the time of post-processing, like at the time of inference, custom models gives me the flexibility to take the input, the inference that generated from my model, and give it some sort of customization. So here, instead of simply saying 0 for not surviving and 1 for surviving, I'm going to say if the customer survives, then I will print survived versus didn't survive. So custom models give us that flexibility to post-process our results as well as perform pre-processing. So in the pre-processing logic, I'm also calling this function which I defined earlier into my feature engineering. This was what I utilized. I was showing earlier that we are going to utilize the same set of functions for feature engineering before we call our model. So this function, if I go back into my functions, is coming from here, my common feature engineering logic. Now here I am going to utilize the MLflow.startrun, where I am going to use my classification pipeline model that I just created and log it into my feature store using the featurestore.log model. So with this, as soon as I go into my feature store and check my feature table, is going to show that now the feature store table that we created earlier, the passenger demographics, is being utilized by a model that is Titanic survival prediction and the version 1. And also the same table is available in my online store, Debu online feature store, which I showed earlier, and it is backed by MySQL in Azure, and it was published last time at this date. So it gives you full lineage of which models are using it and when was it last refreshed. We can also check whether our model is performing correctly or not, like by making some dummy predictions. So here, using the feature store.score batch, I can use the model that I registered and make predictions. So as you can see here, my model is performing correctly. I provided the same set of data values like the raw data set as an input. In your case, when you are working on new data machine learning problem, new data will keep coming and you will be utilizing the feature store library to make this batch prediction. Now let's take a look at the serving of this model as a REST endpoint. So if I take a look here, this is my model. I logged the F1 testing, training and recall. If I go into my UI, in the integrated Databricks ML flow tracking UI, you can get more details about what this particular experiment, what was logged. So here, as you can see here, the feature store, since we were using the feature store API, it has its own area where it has logged in an input example, like what kind of input will be utilized if we are calling this model from a REST endpoint. It also has the requirements.txt, the feature spec.yaml, which essentially contains the information about the features, where they are coming from, feature store, workspace ID, and everything. Those informations are also stored. So now let's take a look how we can use this model for performing real-time inference. I'll keep the input example handy. So I'll simply go in, I'll use this model. So right now this model is not being used anywhere. I'll use this model for inference. Go in real-time inference, enable serving. So this is utilizing the Databricks model serving version 1 right now. So it is now starting my endpoint. Cluster setting is initially, you can see what cluster setting it is going to use, what model, and the model events itself from the UI. So it is pending. We will skip ahead and come back when the model is, this endpoint is up and running. It will take a couple of minutes initially. So now our endpoint is ready. I simply pasted my sample input, which is essentially just the passenger ID and the name. And at the time of inference, I don't have to provide any other feature that was used for model training, because as if we remember, like there were a bunch of other features that were utilized by our model for training. It will actually summarize all the features that are getting utilized. So at the time of inference or in real time, I didn't provide any of those features. So the feature store, feature spec is actually looking up that particular feature from my feature store. Now if I provide any value for the features that were utilized for model training at the time of inference, like new values are provided, they will be utilized rather than the ones retrieved from my feature store. So this concludes my demo of how you can utilize the feature store within the Databricks platform. And as you can see, it is a pretty seamless experience. You can go all the way from doing feature engineering. You already know that Databricks is a unified analytics platform. You can do all your data engineering, land your data into your Delta Lake, and then from there go on and create your machine learning pipelines, just like I showed you. Utilize the feature store, train your machine learning models, and deploy all from the single pane or single workspace without changing the tools. And this is really awesome because it saves a lot of time for data scientists, makes it simple to implement end-to-end like the machine learning lifecycle, and also provides you with a peace of mind that there are very little softwares that you have to maintain on your own. So if you have any questions, do feel to reach out to me, free to reach out to me. Again, thank you so much for attending my talk.